So we're going to continue on with our basic differentiation unit, and we are going to talk about the derivative as a function. So we are going to use the idea that a derivative is a function of x with its own domain and range, and then also use the power sum and constant multiple rules to find derivatives using correct notation. So this is where we begin to learn some shortcuts here. Before we do that, we talk about differentiability. We say that f of x is differentiability on the interval from a to b if f prime of x exists for all x in a to b. So we're going to prove that, and to prove that, we are going to just do what we did in the last lesson and use our formal definition of a limit, or of a derivative. So the limit is h approaches 0 of f of x plus h, and we're going to use just a generic x right now to show that it works, minus f of x divided by h. And we're going to substitute limit as h approaches 0 of x plus h to the third minus 12 times x plus h minus x to the third minus 12x over h. Now, I did a bunch of algebra work off to the side, so I encourage you to, if you're not sure, go ahead and multiply x plus h to the third out. And when you do that, you get the limit as h approaches 0 of x to the third plus 3x squared h plus 3xh squared plus h to the third minus 12x minus 12h, and then minus x to the third plus 12x all over h. So we're going to go ahead and simplify just like we did in the last section. Let's go ahead and multiply or cancel things out. X to the third cancels with negative 12x cancels with 12x, and I believe that is all we can do there. So we are going to simplify by dividing the remaining terms by h. So I have the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 12. Okay, so notice I canceled an h out of each of those terms, and I can plug in 0. So I get 3x squared plus 3x times 0 plus 0 squared minus 12. So my derivative is 3x squared minus 12. Okay, so since we were able to just find the derivative with x in there instead of the point, we know that it exists. I'm going to find f of negative 3, and I'm going to find f prime of negative 3, so that I have those. So f of negative 3 is going to be negative 3 squared, sorry, negative 3 cubed minus 12 times negative 3, which gives me 9 when I calculate that. And f prime of negative 3 is 3 times negative 3 squared minus 12. So when I simplify all that, I get 15. So the slope, or the equation of the tangent line, is y minus 9 equals 15 times x plus 3. Okay, so your derivative is there, tangent line at x equals negative 3 is there. Okay, let's do one more. Prove that y equals x to the negative 2 is differentiable and calculate y prime. Now, because I could rewrite this like this, we are going to assume that x is not equal to 0 because we know that our function is not defined at 0. There's an asymptote there. So we're just going to stick with that there. And we're going to go ahead and find y prime equals the limit as h approaches 0 of 1 over x plus h squared minus 1 over x squared divided by h. And we're going to simplify, so I'm going to multiply by x squared here, sorry, x plus h squared there. And x squared here, so we have common denominators then. And then we have the limit as h approaches 0 of x squared minus x plus h squared over x squared times x plus h squared over h. I'm going to go ahead and multiply this numerator out off to the side so that you have that. That's a lot of ran. So the limit as h approaches 0 of x squared minus x squared minus 2xh minus h squared. And I just distributed the negative right away, divided by x squared times x plus h, quantity squared divided by h. Cancel, and then I'm going to divide. So I have the limit as h approaches 0 of 2x minus h over x squared times x plus h, quantity squared, and then plug in zeros. So 2x minus 0 over x squared times x plus 0 squared, and here is our simplified derivative. So I have 2 over x to the third, and actually I messed up a sign here. I lost a negative. Sorry, negative 2 over x to the third. And so y prime equals negative 2 over x to the third, which is the same as negative 2x to the negative third, assuming x is not equal to 0. Okay, let's get to those shortcuts. First thing is Leibniz notation. There's a bunch of information here, but get used to seeing dy dx or df dx or d dx, and those have to do with our differentials that we will be doing. Okay, power rule makes things a lot easier. If you have something like x to the third power, what this is saying is to find the derivative, you are going to multiply by the exponent to get 3x, and then you're going to subtract 1 from the exponent to get a square. Okay, that's what this formula is saying. And then your linearity rules tell you that if you're adding two functions inside a derivative, you can split them up and take the derivative separately and then add those together. Same with the difference. And if there's a constant in front of a function, we can pull that out, take the derivative, and then multiply by the constant. Okay, pretty simple. Apologize for the typo. This should be t to the third power. But here is the first part. Anytime they talk about tangent line, we need to find the derivative. So if I have f of t equals t to the third minus 12t plus 4, I'm going to start with this first part. I have a power. I'm going to multiply by that power and then subtract 1 from that power. Okay, so I get 3t squared for my derivative. This is really t to the first. So 1 times negative 12 is negative 12. And if I take 1 away from 1, I don't have any t's left. And then the derivative of 4 is just 0. So quick way to find our derivative, a lot faster, saves you a ton of writing instead of doing the formal definition of the derivative. Okay, tangent line is horizontal when slope equals 0. Okay, so remember your derivative is a way to find the slope. So I'm going to add 12 to both sides to get 3t squared equals 12, divide by 3 on both sides, to get t squared equals 4. Do not forget your plus and minus sign. So that happens at two places, when x is 2 and negative 2, and it does specifically say find the point. Okay, find the point or points. So we need to plug those in to the original function to find our points. So we're going to do 2 to the third minus 12 times 2 plus 4, and we're going to do negative 2 to the third minus 12 times negative 2 plus 4. This gives us negative 12 in the calculator, and that gives us 20. So those are our points where the horizontal line is tangent. Or sorry, the tangent line is horizontal. Okay, another notation, find the derivative at t equals 1. So we're going to find g prime of t, which is negative 3t to the negative fourth, so multiplied and subtracted. Rewrite this as t to the 1/2. It makes your life easier. So 1/2 times 2 is 1, and 1/2 minus 1 is negative 1/2. And then negative 4/5 times negative 1 is positive 4/5 t. And then if I subtract 1 from here, I get negative 9/5. Okay, so there's our derivative. dg dt at t equals 1 is negative 3 times 1 to the negative 4th plus 1 to the negative 1/2 plus 4/5 times 1 to the negative 9/5. So we get negative 3 plus 1 plus 4/5. So our final answer is negative 6/5. Okay, and again, you can use your calculator for that. You will have to do this without a calculator in some parts of the AP exam. Okay, how are the graphs related? If you compare the graphs and look at them on the graphing calculator, you're going to start to notice this, and we're going to talk about this in a couple units. But if f prime is negative, that means the tangent line has a negative slope. If it's 0, tangent line is horizontal. And if it's positive, tangent line has positive slope. Okay, and that actually applies for all comparisons of f to f prime. Whenever the derivative is negative, that means you have a negative slope. If it's 0, your line is horizontal. And if it's positive, you have a positive slope for the tangent line. Okay. Last one, and then I'm going to stop this video to talk specifically about the derivative of e to the x. But the graph of f of x is shown in figure 5a, so this first one here. Which graph, b or c, is the graph of the derivative? Okay, so notice until we get to 1, we have a negative slope here. So we need to find the area of, or which graph has the area between 0 and 1 that's negative. And remember, negative is below the x-axis. So right away, I know that this is the graph of the derivative. Okay, so my slope is negative or below the x-axis for our derivative. And then it's positive, so it's going to be above the x-axis. And then it switches to negative, so below the x-axis, and then switches back to positive. So my answer is C. Check out the next video to finish the last couple examples.